This is Mr. B. Welcome to Algebra 1. This is the first lesson in the Flipped Mastery class. You'll be starting with lesson 1-1. Before that, though, there's what's called the chapter opener, and the chapter opener begins on page 4. It's a couple pages long. Read through it. There's good information there. You'll want to also be reading lesson 1-1 about evaluating expressions. You also want to do the practice problems. There'll be an answer sheet with solutions so you can look through those problems and try to decide if you're doing it right. If you're not, figure out what you might be doing wrong and try to fix that. Once you've gone through that, then there's a couple of application problems. So take a look at those and work your way through those. As we get started with this, one of the things you're going to find in just about every chapter is some vocabulary. These are mathematics vocabulary, so something like variable may have different meanings to you, but in the math classroom it's very specific. Algebraic expression is probably not something you use in common everyday speech, but it does have specific meaning to us in math, as does evaluating the expression. So what you're going to do is, these are in the lesson, so you can go find in the lesson where it gives you the definition. You could look in the glossary in the back of the book. So what you want to do right now is to pause this video. When you're done getting your vocabulary written down in your notes, unpause me and we'll carry on with this lecture. Okay. I'm assuming you've gone off, you've taken a look at the vocabulary, you've now got that written down and you know what those terms mean. The other thing we need to understand through this lesson is the properties and definitions that are given. And these are in the tan boxes with blue heading on them. The first one I'm going to bypass because we're going to talk about that in a minute, which is the one about order of operations. We're going to take a look at the others real quick to understand what they're telling us here. The first is the algebraic definition of subtraction. Why do we need this, you might ask? Well, we'll find out when we get to the associative property why it's useful. But by turning a subtraction problem into an addition problem, something that still equals the same thing, we make it easier to manipulate some of our equations around. So this algebraic definition of subtraction is telling us that we have a minus b equals a plus the opposite of b. This is the algebraic definition of subtraction. We can take a subtraction problem, a minus b, change it into an addition problem by taking the opposite of whatever b was. When we say the opposite, the reason I say that rather than negative b is I don't know what number b is. It might be a negative number, in which case the opposite of the negative number is going to be a positive number. So whatever b is, I'm taking the opposite of it when I put in this addition sign. The algebraic definition of division, the same reason we changed subtraction to addition, we changed division to multiplication, because in this case multiplication is associative also. So if I have that a divided by b, it now equals a times 1 over b. This puts us in the form of a multiplication problem. A times 1 over b is the same as a divided by b, but in this form it's associative. Let's look at what these associative properties mean. The associative property of multiplication simply says that we can change the grouping of numbers in a problem, what is grouped with what, and we can do that without changing the result. So if I have something like a times b times c equals a times b times c in parentheses, you'll notice we've moved the parentheses. Those are grouping symbols. We've changed what value is grouped with what, which means we do a times b first here, we do b times c first here, but in terms of the equality, it doesn't change what it equals. Grouping symbols often are found in the associative property, but are not exclusive to it. So be careful that you don't just see that and think it must be the associative property. The other one, and again, for all of these properties, this is for all real numbers. Associative property of addition is that tells us that in parentheses, A plus B, close parentheses, plus C equals A plus B plus C. I'm running out of room. And again, it just says we can change the order that we add these things together in. Instead of adding A plus B first, here I add B plus C first, then I add in A, but they equal each other. So this is the associative property of multiplication, the associative property of addition. This is why the algebraic definition of division and subtraction are useful, because subtraction, neither subtraction nor division is associative. In order to use this property, we need to be in that way. The last one that's in this particular lesson is called the transitive property of equality. And this is just one we often find ourselves invoking it, that tells us that if A equals B and B equals C, then we have that A must equal C. This is called the transitive property of equality, and this allows us to reach some conclusions when we're solving problems with variables. I know I've kind of gone through this. You may not have been able to catch your notes up on it. What you might want to do is go back through this by pausing me, and then when you're done, unpause and continue with the lecture. Remember that this is for all real numbers, for all real numbers, all real numbers, all real numbers, all real numbers, all real numbers in every case. Hey, we're back. Hope you got your notes down. We're heading into order of operations. I know this is a little backward from the text, but I thought we'll come back to it. What you'll see is I wrote up here, instead of PEMDAS, which you might be familiar with, I wrote GEMDAS, but with some parentheses around it. And that's because there's more to it than just what PEMDAS would have you think. Let's go through what these letters mean here. G is for grouping symbols, E, exponents, M, multiplication, D, division, A, addition, and S is subtraction. And this is the order in which we do things. First, we do anything that is inside of a grouping symbol. A grouping symbol is not just a parentheses, but any number of these types of symbols. We might have parentheses, we could have brackets, we could have a radical symbol, we could have a fraction bar. Let's see, we might have kind of a set bracket that we might use. So there are many things that we would call grouping symbols that go together that would fall under this one category of grouping symbols. The next one is exponents. And I think we probably get exponents. This is that little number that goes up to the right of something. So 2 squared is equal to 4. It's a shorthand for repeated multiplication, means 2 times 2, or 10 to the 6th power, which equals 1,000,000. 1 followed by 6 zeros. So these are exponents. So first we do what's in a grouping symbol. Then we follow that with what's inside of an exponent. And then lastly, then we come to the next category, which I put in parentheses, is multiplication and division. And with multiplication and division, what I mean here is we do whichever comes first from left to right. So if I had 2 times 3 divided by, well, I don't know, 4, What this means is this amounts to is I do it from left to right. This is 6. And I'm going to use a fraction bar here, divided by 4, which equals, let's see, they're both divisible by 3, so it'd be 3 halves. This is an improper fraction. That's an appropriate answer in this algebra class. We don't make it a mixed number or anything like that. Well, it's whatever comes first from left to right. So let's see if we do this. Another problem. Okay, let's think of a couple of numbers. I'll have 25 divided by, fraction bar means divided by 5 times 3. And what does that equal? Again, we do this as we come to it from left to right. And we get 25 into 5 is 5, and 5 times 3, which means 5 times 3 is 15. So this helps us understand which way are we going to go with this as we move through our operations. Now the next thing is addition or subtraction. And the addition or subtraction is exactly the same thing in that it happens from left to right. So the order that we come to it will determine when we do it. So let's see, need a couple numbers. I'm going to have 5 plus 3 minus 2. And that's basically, I do these first, 5 plus 3. I'm going to do that first, and then I'm going to subtract 2 from that. So 5 plus 3 is 8 minus 2, which means this whole thing is equal to 6. If we had another problem, we might have, let's get a different color here. Let's say we had 7 minus 5. Ooh, that's a horrible 5. I can do better. May not be able to erase it, but I can do better. 7 minus 5 plus 3. And what does that equal? Now, if I had 5 plus 3 is equal to 8, and 8 from 7 would be negative 1. But this says to do it from left to right. So 7 minus 5 is 2, plus 3 is, the answer to this is 5. So we could see in this problem, if we were to do this differently, in other words, do the sum first and then take the difference, we'd get a different answer. So it's important that we follow the order of operations. This is the way we make sure that we're all doing the same thing, that we're getting the same result as anybody anywhere else in the world who's doing the same problem. Let's get to the heart of this now, which is guided practice. You'll see that there are some examples in the book. You can read through those, look at how they're done, the kind of steps they go through. That's what's expected of you in your work. I'm going to go through some similar examples, but not the same. So I'll give you some alternatives to look at. So for number 1 is a little bit of a order of operations practice. And let's say if we have a case, if b equals 2, find negative 4 times b cubed. So what this is asking us to do, we know what b is, they told us, right? So b is a variable, but now we've defined that variable as equaling 2, so we need to go do a substitution. And so now we substitute in, we have a negative 4 times, you'll notice between the 4 and the b, I didn't put a dot. By convention, if we have a number in front of a variable or some letter, it just means 4 times that. Once I put numbers in there, then it could become more confusing. If I had a 4, a 2, and that raised to the 3rd power, that may not look like 4 times 2 to the 3rd. So I get 4 times 2 to the 3rd power. And we want to know what that equals. Well, order of operations. First we have this -4 multiplication to exponents. There's no grouping symbols, so we're not doing grouping symbols. We do have an exponent, so we do that first. So we have a -4 times 2 to the third, repeated multiplication, 2 times 2 times 2, that's 8. And we have a -4 times 8 is a negative times a positive is a negative. And so that's going to be a -32. So this is our first guided example using exponents, and we get that 4 times 8 equals 32. So there we go. We've got our first one done. Let's take a look at another one and see what that one's going to look like. And I'm going to go ahead and erase some of this. Get us back to this part. And I'm just going to change a couple things. I'm going to go over here and scratch that out and just say, we're going to say number 2. I'm going to change colors so we can see what the differences are here. So I got, if b equals 2, find in parentheses the opposite of our -4b cubed. So now we have a slightly different problem. This does have a grouping symbol, and what this is asking us to find is a -4 times 2 raised to the third power. And now, because of the grouping symbol, that means first we do what's inside of the parentheses. So 2 times a -4 is a -8. And now we want to know what a -8 cubed is. So we would go ahead and do that as repeated multiplication. Since it's cubed and it's a negative times a negative times a negative. There's 3 negatives in there. That's an odd number of them. Therefore, the answer is going to be negative. So I get -8 raised to the third power. And what do we get? Let's see. 8 raised to the third equals. And that would give us then a -512. So quite a bit of difference between the two problems. Again, we can see that the order of operations has an impact here. It determines what we can do, when, and how. Now, if you need to pause this and get caught up, we're heading to example 3. Okay. Sorry, I'm still learning how to do this. I'll get better, I promise. We're going to head into example 3. And example 3 is, let's change colors. Okay, here's example 3. In this case, you could use a calculator to do this. It may be helpful to make sure you know what you're putting into your calculator, and we'll see what we've got from there. So here we have this expression. This is in parentheses, a plus square root of 10 all over b cubed plus a minus 1.5. And that whole thing is going to be squared. And we know in this case that a equals 7 and b equals 2. So now we're going to do a substitution on this problem. and see what we get in this whole case. So it's, what have we got here? I mean, let's just kind of take a quick look. We have grouping symbols, so we're supposed to do that first, but then we go within the grouping symbols and we see we've got more grouping symbols, exponents, and addition and subtraction. So the radical sign is a grouping symbol, but that's just one term in there, so 10 is just that. This fraction bar is a grouping symbol. It means everything up here is grouped over this whole thing as a denominator. So we have to do that before we do anything else. We've got to take care of that addition up there. So now that we know that, let's go ahead and do our substitution. We get 7 plus the square root of 10 all over 2 cubed plus 7 minus 15, this whole thing squared. So now as we want to try to put this in the calculator, you've got to really pay attention to what's happening when, because there is this order of operations to it. So the first thing you would do is you're going to put in 7 plus the square root of 10. You're going to put that in parentheses on your calculator. So you hit a parentheses button, 7 plus square root of 10, close parentheses. Then you're going to hit your division symbol and you're going to get a fraction bar. And you're going to put in 2, and depending on your calculator, you might hit a cubed button, or you might hit a little, we call a caret symbol, meaning raised to the third power, plus 7 minus, oh, this is not 15, it's 1.5. 1.5, okay, 1.5, 1.5, okay. And I needed to have put all this in parentheses, otherwise it would have just done this division and not the addition, right? So this grouping symbol says first I do this, then I have to do that, then I divide it, and then lastly, I'm going to put a bracket around this puppy so we can square it. So here you've got something that you can enter into your calculator, and having written it out gives me a chance to maybe get it right on the calculator. I got a bracket, so I put in a bracket symbol or a parentheses. It could be double parentheses. Parentheses, 7 plus the square root of 10, close that one parentheses. Division symbol, open a parentheses, 2 to the third power, plus 7 minus 1.5, close parentheses, close the other parentheses or bracket, and squared. And now I've got a calculation that I can run through my calculator. And if we take this and we round this to the nearest thousandth place, so I'm going to find that this is going to give me a result of 0.567. Tenths place, hundredths place, thousandths place. So we've rounded this to the nearest thousandths. And there we've got our third guided practice. Okay, we're into the last example here. And in this particular one, we're looking at finding the volume of a rectangular solid. So find the volume of a rectangular solid. A rectangular solid is just kind of like a box, right? It's kind of what it sounds like. We got something that's kind of like this. It's not cubic. And the solid means that it's the whole thing. It's both the outer surface and the inside. And using this formula, the formula for this is that the volume equals length times width times height. You'll notice I'm not putting any dots or any x's in between here. This just means multiplication, length times width times height. And if we know that L equals 4 centimeters, W equals 6 centimeters, and lastly that h equals 7 centimeters, then we've got what we need to go ahead and calculate the volume. This is not really much in the way of order of operations. It's all multiplication. So we just go from left to right. So volume is equal to, let's see, this is our height, so that's 7. And that's our length, which is 4, strange. And our width is 6. So volume equals length, which is 4 times the width, which is 6 times 7. And you notice in this case I'm putting the dots because I need to know that it is multiplication. If I just wrote 467, that's going to look like 467, and who knows what I get with that. And so 4 times 6 is 24, times 7, that's 168. So our volume is equal to 168 centimeters cubed. This is part of the answer, is that it's part of these numbers, rightly so. I should have put it in here. Centimeters times centimeters times centimeters is centimeters cubed, and that's the kind of units of volume. That's it. See you in the next one on 1-2. Good luck on the assignment. If you have questions, please ask somebody, me, somebody else. Lots of people around that know stuff. Bye.